Class continuation, garbage collection. Garbage collection. Garbage collector. The garbage collector is a predefined program. Is a predefined program to perform the garbage collection. Garbage collection. Garbage collection means to deallocate the memory space for unused or unreferenced objects automatically. Garbage collection means to deallocate the memory space for unused or unreferenced objects automatically. Okay. Garbage collection means to deallocate the memory space for unused or unreferenced objects automatically. Any programming language which support garbage collection concept the type of programming languages are called garbage collected languages. Example, Java, Python, .NET and so on. These are all garbage collected languages. In Python, by default, the garbage collector is enabled. Write a program to check whether the garbage collector is enabled or not. Write a program to check whether the garbage collector is enabled or not. Now observing very clearly, Python providing one module that is called GC, garbage collection. Print off, I want to check whether the garbage collector is enabled or not. It is enabled, to give the output is 2. Next, another example. Write a program to enable or disable the write a program to enable or disable the garbage collection. garbage collection. Write a program to enable or disable the garbage collection. Now gc dot disable. Next one, again I want to check whether it is enabled or not. Next one, gc dot enable. Okay, enable the automatic garbage collection. By default, automatic garbage collection is enabled. Next one I am disabling, that's why false. Next again I am enable, that's why we return the true. Write a program to enable or disable the garbage collection. Okay. Next one, before delete the objects from memory location, memory internally destructor will be executed. The destructor will be executed. Before delete the objects from memory, internally the destructor will be executed. Internally the destructor will be executed. Next one, in Python, dunder del is a destructor. In Python, dunder del is a destructor. Next one, once garbage collector is executed, more memory space is available. More memory space is available so that the rest of the program execution become fast. Once the garbage collector is executed, more memory space is available so that the rest of the program execution become fast. Next one, when garbage collector is activated. When garbage collector is activated, scenario 1, observing very clearly, whenever program execution is over. Program execution is over. Whenever program execution is over, then immediately Python memory manager Python memory manager calls the garbage collector comma, the garbage collector to delete the unused or unreferenced objects automatically. Whenever program execution is over, then immediately Python memory manager to calls the garbage collector. The garbage collector to delete the unused or unreferenced objects automatically. Okay, Python memory manager is one program. The purpose of memory manager to allocating and deallocating the memory spaces. Completed. Now observing very clearly. I'm taking as a class test. Here I am defining one constructor. Print I am in constructor. Next one, L. I am in destructor. T1 equal to test class. Next one, printer. By statement. Now observing very clearly. Okay, this is a test class. Next one, this is not executed immediately. At the time of creating an object, it is executed. Okay. Now this is a which statement? Object creation statement. That means in the memory location, one object is created. Okay, now observing very clearly, at the time of creating this object, internally what will be happen? Our constructor is executed. This message is printed. I am in constructor message is printed. Next control will go to this statement. This is a which statement? Print by statement. Now observing very clearly, now our program execution is over. Internally what will be happen? Whenever our program execution is over, then immediately our Python memory manager to calls the garbage collector. The garbage collector go to this particular program memory location. Any unused object is available or not. If it is unused object is available, simply to delete that object. Okay, before deleting this object, internally what will be happen? Destructor message is executed. Internally destructor is executed. Before deleting this object, internally destructor is executed. After executing the destructor, this object is deleted from the memory. Completed. Okay. I am in constructor by message. Next one, destructor message is executed. Completed. Next one, we can delete the objects. We can delete the objects manually by using del keyword. We can delete the objects manually by using del keyword. Now observing very clearly. Now I'm creating T2 equal to test class, T3 equal to test class, delete T2. Write this example. Now observing very clearly. Okay, test class. Now control will go to here. Now this is a which statement? Object creation statement. That means in our test class memory location, now one object is created. Okay. At the time of creating this object, internally what will be happen? The constructor is executed. That means this message is printed. I am in constructor. One time this message is printed. Next control will go to this statement. This is a which statement? This is also another object creation statement. T2 equal to test class. Okay. At the time of creating this object, again this message is executed. I am in constructor. Next control will go to this statement. This is a which statement? T3 equal to test again object creation statement. T3 equal to test class. At the time of creating this object, again this message is executed. I am in constructor. Now, 3 times this message is printed. I am in constructor, I am in constructor, I am in constructor. 3 objects I am created. These 3 objects comes under the which class object memory location? Test class memory location. Now observing very clearly. Now control will go to the statement. Which one? Delete T2. That means we are deleting T2 object from memory manually. Before deleting this object, internally, which one? Destructor is executed. First, this message is printed. I am in destructor. After executing the destructor, this object is deleted from the memory. Next one, control will go to this statement. What is the statement? By statement. Now this message is printed. Up to now, I am in constructor 3 times. Next one, I am in destructor and the by statement. Now our program execution is over. Once our program execution is over, internally what will be happen? Internally what will be happen? Our Python memory manager to calls the garbage collector. The garbage collector go to this particular program memory location. In that memory location, what are the unused objects are available or not available? If any unused object is available, simply to delete that object. Now in our program memory location, how many objects are available? 2 objects are available. Delete this T1 object. Before delete T1 object, this message is printed. I am in destructor. Next, this object is deleted. Next one more unused object is available. Before deleting this object, internally what will be happen? Again, destructor message is executed. Next one, this object is deleted from the memory. This is the output. 3 times I am in constructor, I am in destructor, by statement. 2 times destructor message again is printed. Right. Next scenario 2. Whenever object reference count is whenever object reference count is 0, then immediately our Python memory manager calls the garbage collector the garbage collector to delete that object from memory automatically. Whenever object reference count is 0, then immediately our Python memory manager to calls the garbage collector to delete that object from memory automatically. Completed. Now observing very clearly. I want to find the object reference count. I need to require one module, sys module. Now I want to find the reference count, sys dot get reference count of object T1. Here I am not creating an object. Simply I am assigning T1 address to T2. Again, I am finding the reference count. T3 equal to T2. Again, I am finding the reference count. Next one, here I am creating new object. T4 equal to test class. Now again, I am finding the reference count of T4. I am deleting one reference variable T3. I am finding the reference count of T1. I am deleting T2. Next one, delete T1. Now observing very clearly. Okay, import this model, test class, control will go to here. Now this is a which statement? Object creation statement. That means internally in the memory location, one object is created, T1 equal to test class. Okay. Whenever we are executing the statement internally, here one message is printed, I am in constructor. This message is printed. Next one, sys.get reference count of T1. This is an object. Now I want to finding the reference count. I want to finding the reference count. Okay, reference. This is a which one? Object creation statement, but this is a which variable? Reference variable. Reference variable equal to class name. Next one, inbuilt in Python, one reference variable is available. That is called self variable. Self is nothing but a one reference variable. Whenever we are creating any one object in Python, that object having two references. Here T1 is a one reference and self is a one reference. Now the reference count of this T1 is, what is the reference count of T1? 2. Next one, T2 equal to T1. That means here I am not creating new object. Already T1 having some address. Now same address is passing to T2. Now this is an object. How many references are there? T1 is a one reference. T2 is a one reference. Inbuilt self is a one reference. Totally the reference count is 3. T3 equal to T2. That means T2 having same address. Same object address is passing to T3 also. Now how many references of this particular object? T1, T2, T3 and self, totally 4. Now T4 equal to test. That means one more new object is created. T4 equal to test class. Okay. Next, observing very clearly, T4 equal to test class means this is one object creation statement. Now here also one message is printed. What is that message? I am in constructor. That message is printed. Next one, get reference count of T4. Now, how many references are there this particular object? How many references? T4 is a one reference. Internally, self is a one reference. Totally 2 references. Next one, delete T3. Now I am deleting this reference. Now, how many references are there this particular object? How many references? T2, T1 and self. Next one, delete T2. Now, how many references are there? 2, T1 and self. Okay. Next one, delete T1. That means I am deleting this T1 object. That means there is no reference to this particular object. Okay, without reference, Self is not a reference variable. Compulsory one object creation is required. Then only self act as a reference. But suppose I am deleting T1, there is no object creation here. That means what is the reference count? Now internally reference count is 0. Whenever object reference count is 0, internally what will be happen? Our Python memory manager to call the garbage collector to delete this object from memory. Whenever we are deleting T1, now object reference count is 0. Whenever object reference count is 0, internally what will be happen? Our Python memory manager to call the garbage collector to delete this object from memory. How to delete that one? Before deleting, which logic is executed? I am in destructor. Next one, this object is deleted from memory. Whenever we are deleting this object from memory, now here we will get one message. I am in destructor. This message we are getting. Next one, this message is printed, by message is printed. Now our program execution is over. Okay, once our program execution is over, internally what will be happen? Our Python memory manager again to call the garbage collector, go to this particular program memory location. Go to this particular program memory location. What are the unused objects are available or not? This is a program memory location. Okay, how many objects are available? Still, this object is available. Now, to delete this object. Before deleting this object, internally what will be happen? Again, which message is executed? Destructor message is executed. Okay, this is a destructor message for this object. This is a destructor message for this particular object. So write this. Okay, I am in constructor 2, 3, 4. Again, I am in constructor 2, 3, 2. I am in destructor. By statement again, I am in destructor. Next one, types of methods. In Python, we can create a methods in four ways. First one is instance methods. Second one is class methods. Third one is static methods. And fourth one is abstract methods. Instance methods, class methods, static methods, abstract methods. Completed. Next one, instance methods. Instance methods. We can create a instance methods. We can create a instance methods. Don't require any decorator concept. can create a instance methods. Don't require any decorator. Decorator is also nothing but a function. Decorator is also nothing but a one function. Okay, later we will discussing decorators concept separately. Decorator is also same like as a function. Completed. The instance methods. The instance methods takes the self as a default parameter. The instance methods takes the self as a default parameter. Takes the self as a default parameter. Next one. In instance methods, we can access both class level, that means static, and instance level, that is a non-static data. In instance methods, we can access both the class level, that is a static, and instance level non-static data. In instance methods, we can access both the class level data and instance level data. Next one, we can access the instance methods. We can access the instance methods from outside the class. By using reference variable only. That means compulsory we need to creating an object. Syntax, class name, def, method name, self as a default parameter. We can access the instance methods from outside the class by using reference variable only. Completed. Next one, static methods. Static methods are class methods. Class methods, second heading. The class methods. We can create a class methods. To required class method decorator. We can create a class methods to required class method decorator. The class methods takes the CLS as a default parameter. Observing very clearly. Here, previously we were discussing self. Okay, self is nothing but the instance method. It takes the parameter as a instance. Instance. Self means instance. Next one, coming to here, CLS means internally it will be take the class name as a parameter. CLS means class name as a parameter. Self means instance as a parameter. CLS means class name as a parameter. In class methods, we can access only class level. That means static data. In class methods, we can access only class level data. But previously, in instance methods, we can access both class level and instance level. Class level means static, instance level means non-static. But here only access the static data. We can access the class methods from outside of that class by using class name or reference variable. We can create a class methods to required class method decorator. The class method takes the CLS as a default parameter. In class methods, we can access only class level data. We can access the class methods from outside the class by using class name or reference variable. Method name or class name. Okay. If you want to make any method as a class method, what is the requirement, major requirement? We need to require class method decorator. Okay, class method is a one built-in function. If you want to use our method as a class method, above our method definition, we are using class method decorator by using one annotation that is called @ symbol. The decorator name is class method. The decorator name is class method. Def method name CLS. Now this method acts as a class method. Okay. Next one, static method. We can create a static methods. To require static method decorator. We can create a static methods to require static method decorator. Static method decorator. The static methods, the static methods don't take anything as a default parameter. Default parameter. The static methods don't take anything as a default parameter, but instance method take the self as a default parameter. That means the instance. Next one, class method take the class name as a default parameter. But here in the static method, don't require any default parameter. Generally, in static methods, we are using some generalized data. It's like static. That means a local data. Generally, in static methods, we are using some generalized data like as a local data. We can access the static methods from outside the class. We can access the static methods from outside of the class. From outside of the class by using class name or a reference variable. We can access the static methods from outside of the class by using class name or reference variable. Class name, some attributes, @ static method, name, don't require any default parameter. Completed. Now observing very clearly, I'm open the Python manual. We go to Python documentation. In that one option is available, Python standard library. Click on the built-in functions. Now observing very clearly here, class method is available. That is a one function. Now observing very clearly. Okay, how to use that one? @ class method. Transform transform a method into a class method. If you want to make any method as a class method by using this annotation, @ class method. Which method we want to take the class method? Above that method definition, we are using this one. That is the syntax. Next one, a class method receives the class as an implicit post argument. Are we clear? Just like an instance method receive the which one? Instance. That is nothing but a self. To declare the class method by using this syntax. Compulsory this syntax we are following. The @class method form is a function decorator. Okay. At the end of the Python class, we will discussing how to create our user-defined decorators. These are all built-in decorators. How to create our user-defined decorator, everything I'm explaining. Next, one more function is available. That is a which one? Static method. Okay, transform a method into static method. A static method does not receive any implicit post argument. Okay, static method don't take any default parameter. This is the syntax. Which method we want to take the static method? Above that method definition, we are using this one. Okay. Next class, I am explaining one example for these three methods. Okay, here one more method is there, abstract method. If you want to understanding this concept, we need to require inheritance concept. After completion of the inheritance, once again, I'm explaining abstract methods.